From 5G networks to aerospace systems, from artificial intelligence to quantum technologies, from behind the scenes of innovations to real-world applications. Welcome to Innovations Unplugged, the Rohde Schwarz Technology Podcast. Hello, I'm Inga Müller-Siedentop.
And I'm Markus Haller. In today's episode, we are pulling back the curtain on a technology that quietly powers the world's most advanced innovations, the Vector Network Analyzer, or VNA.
Maybe you have never heard of it, at least I had never heard of it before I started working at Rohde Schwarz, but for 75 years, it's helped design wireless communications and radar systems, from smartphones to satellites, electric vehicles to 6G. VNAs are the tools behind the tech.
And as if that weren't impressive enough, the Vector Network Analyzers were born at Rohde Schwarz in the 1950s. That's why we're celebrating its birthday today and its legacy, while looking ahead at how it's shaping the future.
Joining us is Michael Fischlein, one of our top Rohde Schwarz experts for network and spectrum analysis. He knows the VNA inside and out and why it's more relevant now than ever. Welcome, Michael.
It's great to be with you guys here.
So, Michael, let's start with something close to home. If I'm texting a friend or streaming content, if I'm navigating with GPS in my car, or even listening to this podcast, how does the Vector Network Analyzer enable these technologies?
It's maybe a hidden champion behind all these technologies. So network analyzer is measuring radio frequencies and the behavior of radio frequencies in circuits, for example. Yeah, is a tool to help the engineer to understand what is the performance of the individual components. RF components like filters or amplifiers. The network analyzer is a tool to go for the engineers in R&D, production or characterization.
It's a tool engineers across the electronics industry use in the background. It impacts our everyday digital lives. But most people have never heard of a VNA. How would you explain what a vector network analyzer really does?
A network analyzer is making use of so-called S parameter. And based on this S parameter, you can say, okay, how much is a signal amplified or attenuated? Or how far a signal is reflected? And later on in the design flow, you're putting all these ingredients together, and you get then the overall performance from antenna to the digital backend of a laptop, of a Wi-Fi router, for example. And each individual stage will be optimized by a vector network analyzer. Thinking
about that, why haven't we heard more about it?
Yeah, so first of all, they are everywhere, and we are selling our VNAs in 99.9% of the cases to B2B. Yeah, so business to business to our customers. Yeah. And the nice thing is we are working with them also, because they're coming to us and asking for the measurement challenge. Yeah, and we have to come back with a solution to them. And this interaction also is a typical Rohde Schwarz style, I would say. Yeah, that we are working close with our customers and want to understand the customer problem and want to solve it.
And to understand how VNAs became so essential, let's take a moment and look back. Imagine being a radio frequency engineer back in the 1940s. After World War II, radios were common, black and white televisions were just starting to make their way into homes. What was it like being an electrical engineer back then, before vector network analyzers?
I think the time before VNAs, the circuits were not that optimized as it was on the later stage. To give you an example, we are talking about sustainability, of course. Yeah, how much energy consumption is really required to transmit from A to B. And a vector network analyzer helps to optimize this kind of parameters. Yeah.
Maybe to give you a catchphrase here, I remember reading an article from, I think a colleague you might know, Michael Hiebel.
Sure.
And he was giving, he had a nice phrase, and he said, back then it was the days of the slotted lines. Can you elaborate a bit on that?
First of all, greetings to Michael. Hope you also hear the podcast. On these slotted lines, I think the difference is just simply the effort an engineer needed to spend. For us in our DNA, it's always to think about the customer problem. And the customer problem that time was, okay, it takes a hell of time, really, really long, to gather the measurement data. It was a highly manual and error-prone work. And then in the 50s, we started to think about how to make the life for our customers easier.
The year 1950 marks a milestone. Rohde Schwarz engineers laid the foundation for modern vector network analyzers. The Z-g-Diagraph was the first instrument to show complex S parameters on something called a Smith chart. Michael, please fill us in. Why was that a breakthrough?
Oh, the Smith chart, I still know it from the university. So first of all, this is something you learn as an electrical engineer. If you are choosing the right specialization, you learn about Smith charts.
Thank you for explaining. I didn't know before.
Yeah. And the beauty of this diagram is you see immediately the amplitude and phase information in this kind of representation.
When you talked about the beauty of the instruments, it's about visualization. Because before you had data, but you had to analyze it manually. And now you have a chart that already visualizes your data, right?
And this was back in these days, the innovation in the end.
How much time did it take to get from your data to a Smith chart?
I think in former times it took hours. Now we are then down to less than maybe half an hour or something like that. Yeah, so it was much faster.
And now we're starting to see why this is a big innovation, to have all your data suddenly on a Smith chart. Already, you don't have to calculate, you just look at the screen and you know what's happening without calculating. That might be error prone, takes time. Maybe it's a bit frustrating for engineers. Yeah. Let's fast forward to today. VNAs are compact, they are digital, often fully automated. How has the VNA evolved from an idea in a German lab to a test and measurement instrument with global impact?
Today, we are looking into to enhancing all the tool set of a VNA. In former times, it was just small signal S parameter thing. Yeah. Now coming back to an amplifier example, when you inject 1 watt, the amplifier has a gain of 10, you will get 10 watts out of it. But it doesn't scale until 100 watt or whatever. Yeah. And therefore, you will see nonlinear effects. In daily life, you see this if you turn on the volume of your smartphone or whatever, when you listen to a podcast, for example, and you turn it on and on and on, the effect is getting less and less clear. This comes to the point that we are driving an amplifier in a nonlinear region.
I think every audience is trying it right now.
We are supporting now on the customers on this use case. The other side, turning the volume smaller and smaller, then you're also going to have an effect of hearing noise, for example. So we are very, very quiet here, and then you also see that the quality will suffer of the podcast, Yeah. So in the end, you can also measure, it's called noise figure, You can also measure then, it's called frequency converting components. You can also measure more and more higher frequencies, So in former times, the tool, it started maybe at 100 megahertz, But the communication systems are evolving and the frequencies are getting higher and higher. So to name an example, in former times, the mobile communication were available maybe up to 4-6 gigahertz around that range. But on 5G, we have FR2, then we are talking about a frequency from 24 to 52 gigahertz, for example.
VNAs, they started as pure laboratory tools, but now they are also very common in production environments, right?
Yes.
Give us an example that everyone can understand. How does a production environment look like when VNAs are in the cycle? how can we picture this kind of production environment?
Yeah, so first of all, you need to imagine that a VNA in production doesn't have these very nice display. The customer requirement is to build an instrument as compact as possible. Yeah, you see in the end an instrument with a lot of connectors. Yeah, so it's
no
not very
display, no knobs.
No display, no knobs, nothing.
So back to the general box kind of thing with a lot of inputs.
Yeah, with a lot of inputs, and then connected to a so-called handler. Yeah, and the handler is taking the component under test out of a reel, put it into the test fixture, and then we will test it, measure it, and then the next component is coming. Just to give you an example, in a smartphone, we're talking about around 20 filters, maybe more, sometimes less. And all these 20 filters are tested 100%. You need to imagine that how many filters in our smartphones. So, I think I have 2 smartphones, right? Yeah. So maybe we're talking about now 10 billion smartphones over the world, and all these filters are tested.
Can you give us facts and figures, like in numbers?
Yeah, maybe we're talking about, I know it from one customer, around 10 million filters around that per week. Per week. So not per year, it's really per week.
And everyone is tested.
Everyone is tested.
Wow.
And then you need to imagine, of course, when we talk about, so microseconds is one measurement point now, and you are sweeping maybe 200, 1,000 points and so on. Now you can calculate that a measure takes milliseconds. Yeah.
And that's just the sweeping. You also have to include the connecting of the filter to the VNA. Roughly how much time do I have for all of it? Are we still in milliseconds?
Oh yeah, it's still in the millisecond range, and it's really impressive when you see it in a production line how fast this mechanical movement is. Yeah.
So we talked about mass production kind of a lot, and that makes me actually curious about the other side of it. You are a leading expert at Rohde Schwarz in the field of network and spectrum analysis, and you have been with our company for over 25 years. What's the most unexpected use of a VNA that you've come across? Is there any?
Yeah, of course. You will be surprised where VNAs are used. Yeah, very nice story I got from Jamie. He's an application engineer out in UK. Greetings to Jamie as well. And so he had a customer. He did some research on, or is still doing research on black holes. Yeah,
I did not expect that.
Yeah, I didn't expect that either. Yeah. And what they are doing is they are generating a signal with a VNA, they're sending it out of space. Something is reflected, and this something needs to be analyzed. But the dynamic range required. So dynamic range means what I'm going to inject in my device under test. This is a black hole, the device under test, and what is
very far away,
far away, yeah. And what comes back from the device under test, and there is a lot of attenuation in between. So you're going really to the physical limits here.
That sounds really fascinating.
Yeah, the instrument in that condition is very sensitive. Yeah, there was even for the first amplifier, which is used, it's cooled down to 0° Kelvin, or almost 0° Kelvin.
Okay.
Yeah.
Just to emphasize this, we are not talking about 0 degrees Celsius, but as cold as can be, and
yes.
I guess it's roughly minus 273 degrees Celsius.
Something like that, yeah.
So that's amazing.
Yeah.
We have heard about the VNA's history, and we've heard about why they are so relevant today. So let's talk about tomorrow.
Okay.
How do, Michael, vector network analyzers support cutting-edge technologies like quantum, like artificial intelligence, or satellite systems?
Yes. So first of all, when we talk about quantum, a network analyzer is used to calibrate the system. Have you ever seen a quantum computer? Of course, yeah. A very futuristic thing, yeah, and with a lot of cabling, yeah, these silver shining cables, and all these cables needs to be calibrated. That the phase at the end of the cable is on all the inputs the same. And this is one step. and later the thing is calibrated. We have then a second part of it where we have solutions from Zurich Instruments.
Spoiler alert, Zurich Instruments is one of our subsidiaries that is dealing with system measurement instruments, especially for quantum computing control systems. And we will cover them in one of our next podcast episodes. So
okay.
Stay tuned.
So that was quantum. Can you tell us a bit about how are VNAs touching AI, if they do, and satellite systems?
When it comes to AI, we see there is a massive amount of data centers are built.
Yes.
And the big problem in these data centers are the cables. So the connecting the different building blocks of a data center together. Yeah. So you have very high data rates, and these are very expensive cable. These cables is one of the big obstacles or problems putting a data center into operation.
The bottleneck is the data cable.
Yeah, really, the data cable is something. If one of these cables are broken, it costs a hell amount of money for our customers to get it exchanged or identified. And therefore, again, similar as on the filter we mentioned before, all these cables and data centers are 100% checked.
Actually, every cable is checked in production, right? Is that point?
Every high-speed digital cable is checked in production, yeah.
But just a quick question on that. The data center and looking like ahead, looking into the future, cables are also evolving. We are coming from traditional kind of classic cables going towards or heading towards optical fibers.
Yes.
Is that something that vector network analyzers will still cover, or is that something totally different?
Oh, good question.
Yeah, so you can indeed use a network analyzer together with an electrical to optical converter or optical to electrical converter, also together to characterize and measure these kind of optical cables as well.
Okay.
So even here, when we're looking to the future, or I think when longer cables are required, in the data centers, they are making use of optical. Yeah.
Okay, check. So we do have work in the future.
Yeah, for sure. Yeah.
All right, and some comments on satellite systems.
So first of all, it's amazing how fast the new space industry is evolving. And of course, they also have measurement problems. Yeah. In the past, I think when you are sending out a satellite into the orbit, I think it was a lot of steps done to characterize or to measure the transmit and receive part of a satellite. But today, I think they are sending out much more satellites, so 10,000s of satellites now into the orbit. And of course, they don't have the time to characterize each single parameter of a satellite. Yeah. So also here the trend goes more into measuring faster. This is definitely something. We see also trends that definitely we are reaching higher frequency ranges and also different kind of communication when we're talking about modulation schemes. Yeah.
We're talking about rapidly evolving technologies. So does that mean for VNAs, they not just have to cover the current specifications and measurement needs, but also be kind of future-proof? Is that an issue or something you think about?
Yeah, when we look into the customer scenarios, I think we need always to have around maybe 10 dB better specifications than the device under test of the customer. So we always need to be better, of course, as a test and measurement vendor or a solution provider compared to what is required by the customer. And it depends, what our customer need. Yeah, if they are looking into really going into the physical limits, we have to try to push these physical limits. Yeah.
You also need, I guess, to anticipate future technological needs, right? So in designing a product, how do we as Rohde & Schwarz do this?
Looking ahead maybe 2, 3, 4, 5 years down the road, you can anticipate what happens. Are we moving into higher frequencies? Are we moving into more bandwidth or higher bandwidth requirements? Are we moving more into a better performance? This is something where we are close to the customer, which are looking really ahead and into the future. Where are the trends?
And since you are not just a technician, but also a manager, putting all this into the perspective of company culture, what do you think sets the company Rohde & Schwarz apart when tackling these tough technological challenges?
Yeah, first of all, what you're doing, for example, in R&D, you're doing engineering art. So you're learning the basis, like on Smith's chart, what I mentioned before in university. Yeah, but one thing is a basis, but the other one is really to use it to build a test and measurement instruments, which is really also appreciated by our customers in terms of accuracy or measurement speed or whatever. Yeah. And therefore, a lot of knowledge is something you can learn on VNAs, and you can be part of a big team. It's a team effort, yeah. And this is first of all a very nice thing. Also in my VNA R&D group, very young and ambitious guys, and I really love to work with them, yeah. But you have also, of course, in VNA other interfaces, yeah, to our customers, to product management, even to production. Yeah, it's really nice, and which motivated me as a young engineer when I started at Rohde Schwarz. Yeah.
Right. Actually, I just wished that our audience could see the sparkling in your eyes when you were talking. So it's always nice to talk with someone who's passionate about that.
Yeah, I'm really excited about VNAs.
After 25 years still
excited,
which is something cultural with this company, right? Yeah. You already put it before, like pushing boundaries is something that needs to be done in that field, right? That reminds me of a quote of one of our founders, actually. It brings me back to that one. In Germany, it goes like, wir müssen den Stein weiterwerfen. That means here at Rohde & Schwarz, innovation is in our DNA, driving us to constantly push the boundaries of technology. Do you feel that?
Oh, for sure. I have also a nice example where I just started a development where we are really working together, gathering the market requirements, and also had great ideas from R&D to really push the customer problem into another level. Yeah, it's really, we recently started a project. It was amazing to see how the different teams are working together.
That actually is a great close for our podcast for today, I would say. Thank you for sharing your excitement. I felt it. I hope our audience did get the same feeling. You are still full of enthusiasm for your field of expertise. Thank you for being with us.
Yeah, it was a pleasure. It was fun. Yeah.
Yes, Michael. Thanks a lot for this interesting conversation.
If you liked that podcast, if you liked what you heard from Michael today about VNAs, it might be interesting to tune in again another time. So feel free to subscribe to our channel.
And make sure to check out the show notes for some additional material to this episode.